Hello, hello. Everyone is all right, I hope. Okay, so I think we want to do some more work on the small Zig demo that we worked before. Let me get everything ready. Okay, so what do we need? We need we need C-line and the small project. We also probably want to start up the Zig plugin so that we can check if something is supposed to work or I just do something wrong. Okay, what else do I need? I think I should make sure that I see chat. Okay. All right, and let me start up this one. And then we can maybe switch here and show everyone what we try to implement in Zig. So I made some progress offline. So I was able to fix basically the debugger issue. And that was really a weird one. So what we tried to do was simply using the debugger and stepping through the code within C-line. And it was not a problem of the plugin, to be clear, and it was not a problem of C-line. So what it was a problem of was that so we had two choices for the debugger. It was LLDB and GDB. So with GDB, the problem was that you could not set breakpoints in files. So if you set a file breakpoint, the debugger couldn't locate the sources, and therefore you could step into it, right? But you could only see assembler, and that was useless for the thing we tried to do. And with LLDB, the problem was that it needed I think a Zig type system to understand how to display all the types and data structures, but that's only a guess, right? So, and both problems appeared also if you started the debugger on the command line, just with the command line interface. So it was had nothing to do with Zig in particular. So not with Zig, with the plugin for the language in C-line in particular. So, and the unfortunate thing was that I tried to find information, but there was not too much available. It seems like no one really cares about a debugger in Zig. So what I did find were some information about an additional plugin for LLDB, but that didn't help me because it turns out I probably needed a specific LLDB version, a Zig LLDB version. And I looked into that repository, but I think it was pretty old. I think the last commit was, I don't know, 3 years ago or something. So I didn't play around with that. And then I don't know where I found it, but someone said, or somewhere something said that you needed in your build, you needed to make sure that you have this option turned on. Use LLVM, set to true. And if I did that, the GDB debugger worked and it could find the source file. So with that being said, what we can do now is we can put a breakpoint here like this one or that one right here. And then we can simply debug the thing and it starts up. And we not only break there, because I had also, before I had the situation where it would break and you could step through the code, but you couldn't see any variables in the frame, right, of the frame you're currently in. So now we see everything. Of course, the complex numbers are structs and they are not supported. So, but we can still open them up and see the values inside, and it's not a big deal. The good thing is we can simply basically step in. So with that being said, one of the things I wanted to try out before we continue is to set a breakpoint and make it dependent on some data. And I'm not sure if that works. I'm not sure if it's supposed to work, but so what I want to do here is, let's say we go here, click to main, to more, and then we have this this breakpoint here. Let's use, I don't know, what was that one? That was this. Okay, so yeah, we use that. We can get rid of this one here. We don't want to break for any. So, and here I want to say, okay, so can I input a condition? So is that possible and does that work? So for instance, we got the arguments here, so we will keep it simple. So let's say we want to say D1 is smaller than 0. Okay, now let's stop it and debug it again. Okay, it breaks because obviously D1 is smaller than 0. So let's say if we do that, nice. So see, now it didn't break, and we can have basically data dependent breakpoints. So what else could we do here? Use file name only, enabled, suspend action, conditional. What else we got? So evaluate and log. Let's see if that works. I'm not sure if that's supposed to work, right? Where this is coming from, if the plugin has to do something specific. So let's say we want to just log that here. And we want also to remove once the breakpoint hits. Done. So, okay, let's do it again. No, it didn't break. No, because it didn't change the condition. Was the logging still there? Oh no, it's not here. Okay, don't remove it. Just say D1 plus D2. Is it there? So yeah, done. Okay. So it hits. And if we continue, live watches, no, no. Oh, and here we got the log message. So the basic things seem to work. Okay, and then we can now we can basically continue. So okay, where did we leave all this? So I fixed the debugger. I also fixed how, okay, so that because I needed to read some stuff for that. So how we basically work with arrays. So what I did now is this filter here, the 1D filter, right? It gets an input array. It filters this array, and then we need to store or return the output somehow. So and what I did is basically I give the output array as an argument, and we can store it there. And also I read up about allocation and how it works. So basically the temporary stuff that we need, right, is now allocated on the heap. And this is also, that was also new for me. So I provide the allocator where it's allocated. It's used here. We allocate the temporary stuff that we need, and we also say just defer, basically freeing the memory at the end of the function when all the work is done. I think that's how this works. Okay. Right. Was there something else? And in main, oh yeah, I tried to do a small demo with Raylib, but I think we need to adapt the build file for that. And I guess we need some help from a GBT there to find out exactly what we need to change and how we can include the library and all the things that we need. Okay, so but here I basically, let's do something different. Yeah, so I create a variable for the array because we wanted to measure the, and I, exactly. So what I did is I verified that the filter is indeed correct, right? So we send in a unit pulse, which is all zeros except in the middle where we have a 1, and then you filter it, and then you see the impulse response, and this is the defined behavior of the filter. And if this is correct and is the same as my reference implementation, then hopefully it's good enough. And it was pretty close. There were some small numerical errors, I don't know, in the 7th place or 6th place after the comma, but that's okay. We only use 32 bits, and my reference implementation uses, I guess, more bits, at least 64, I think. Okay. So, right. Okay, and I can just run it, and you see basically what I did here is it just prints out the filtered result. So we put in all zeros and one in the middle, and it gets that back. And we can probably also draw that, right? So I can take that here like this. Oh yeah, it's a copy. It's just Control C here. And then we can head over to Mathematica and just scroll down. And then we can say something like list line plot, and then we put in all the numbers, remove 0. And you see it's pretty much a gradient filter. Perfect. It's exactly what we want. Okay. What else? Oh, right. Exactly. I wanted to. So how can I do that? Let me see if I can. If I type a message like Discord. Yeah. Where's my? Is the text to speech working? Let's go to my channel and say, hello, is TTS working? No, it's not. Hi, Hi, Broston. Why is TTS not working? Okay, so there was a setting for that. Customized chat here. It was somewhere here. Appearance. Let me see. I want TTS because that was really great. Notifications. Yeah, why is it disabled? Okay. So we got UK. Do we also have Australia? No, we don't. We have Google, Google French. Okay, so let's see if that works. So, and do I have to, I can't save this. Let's see. Okay, I'm just heading back. Okay. Oh, now the message is coming. Okay, so this is the Discord server, by the way. Feel free to hop in. So let's try TTS again. Do I really have to keep the thing open? It's off again. I need to keep it open. That's really weird. Okay. Let's try it again.
Halarutan. Let's try it again.
Okay. But that is far too American. We want British. Okay. So since that works, choose how you're alerted to new chat methods, including text-to-speech. So how can I save that? There's no save button on this. That's weird. Okay. So we got that. The filter works. So, and we have basically two options now. So
Broston 45 is a livey.
yeah, it's live. So we have two options. So the first option is that so now we can filter one line, right? We can filter one line of the image. So we would need to go to say, okay, an image is basically a matrix or two-dimensional array, and we filter everything in one direction, in the other direction, and then we put it together. So that will be a tiny bit of work. Or we continue and we try to get a Raylib window open, and so that we know, okay, Raylib does work, and we just have to think about how to get the image on the screen. This will be tedious because probably it contains lots of looking around how this is done in the build file, and I have no clue about that, so probably we should start with that. So for this, okay, let's see. So GitHub zig raylib. There you go. So manually tweaked auto-generated raylib bindings for zig. Okay, so this is the example. That's what I just copied in. And we can go here and say, yeah, of course, uncomment everything. And then I think we need that. And then we also need the import. But I think that's not enough, because when I try to build it and run it, we get an error. So let's go to build and run. So, and it says no module named Raylib available within module root. Okay, so what that means is, hopefully understood it correctly, that we added an executable here, random gradient effect. I'm a bit hesitant to remove all the helpful comments because they are pretty good, but for the sake, so okay, we keep them in. So basically our build file is just creating a public function build, and then we define a module, okay? And there is no raylib here.
Stream elements. Thank you for following Yasidin.
Okay. Hi, Yasidin. Welcome. Okay, so and if okay, so don't make that. I didn't make that clear. So if anyone has an idea, right, feel free to just jump in and tell me how to do it. So right now we want to add raylib to this very small thing so that we can open a raylib window with Zig. So I think we need to add it to the module somewhere here, but I don't know how. And one of the things we could do is we could just check out how it's done in the raylib GitHub repository, because they also have a Zig file, right? A build Zig file. And so, but how do you add module? Okay, so the problem here is that it's not a clear. So maybe we should check out for real examples, right? So they have an example folder, but it's just a subfolder. So if we understand how this works with the subfolders, we have this here, target, we got that, get options. So here we got raylib dependency, okay? Where is the raylib dependency used? It's used here, and okay, so here are the examples. It's an array of program, okay. And it doesn't specify that these need raylib, but maybe it's not necessary because they're within the repository to begin with. So, okay. So for each example, do the following. We got a module, create module. Root source file is the path. Target and optimize. Then there's something with that I don't understand. Add import raylib. Okay, so but we don't need WebAssembly. Else, okay, so else add executable, exa root module add import raylib. exa.root module add import raylib. And raylib was what? Okay, so let's see if we find examples. So raylib Zig examples. So here you go. Basic window. It doesn't have a I think that's different because this is raylib-zig and we are also using raylib-zig, okay? Ported to zig. Using zig raylib bindings of raylib zig supported platforms. So let's see. But this seems to use the original raylib. Okay. So what we're going to do is we will use some GPT for that and ask if it can help us. So let me make that. So this is called random something. Okay, and then we just make a docs whatever. We say git clone, and then we get this one here, the original one. Get code, yeah, git clone that. Probably just a shallow one. Okay, then we'll say open code and plan mode should be enough because we want to understand it, so we just want an explanation how this is going to work. Okay, so in this project I want to use the, is it called raylib-zig? Raylib-zig, is that correct? Docs, raylib-zig, yeah. The raylib-zig library. For research, you find the repository in docs and here. Your task is to explain in detail what I have to change in my build okay, I think it's the build, to use raylib-zig. I do not want to use the local copy, but instead rely on the online dependency as specified specified in. Again, I don't know if that even makes sense, right? It's just my mental model. Okay, so it's defined here. My mental model that I have. So I think it works like that. I got the dependency here. So if it needs to look for it, it will download it just here. And then it needs to, I don't know, in C, you would say, okay, it needs to know where the includes and where the library is.
Stream elements.
Raylib is...
https://discord.gg/2userkdczkf.
Okay, that's fine, but maybe you should not read URLs. Do not read links. Okay. Right, so you need basically the includes and maybe you need a library, but for Raylib, I think it's includes only. I don't know, not sure exactly. Probably not, but it's pretty easy to use in C. I did in a small demo once. So, okay, so I don't want to use localcopy, instead rely on the online dependency as specified in, okay, and this is specified in build zigzon. Okay, go ahead. I will just get something to drink while this works. Okay, now let's start from the top. So your build zigzon is already set up correctly for the online dependency. Okay, so that's good. The only thing you need to change is build zig. Okay, so that's what we figured out already. Resolve the dependency from build zigzon with b dependency raylib zig. Okay, so this is the name here and probably, okay, get the zig module raylib from that dependency, all right. Get the compile C artifact raylib from that dependency and link it to your executable. Add the raylib module to your executable root module imports so that import raylib works in okay, perfect. Why both module and artifact are needed. So raylib dep module gives zig sources access to the bindings. So this works. Okay. Raylib dependency artifact raylib gives the actual native raylib library that must be linked, otherwise the build will fail at link time. So basically it's glue code in zig that calls into the original raylib, I guess. Minimal change for your zig, for your build zig. After the, at this after target and optimize are created. So raylib dependency. So what is B? I don't know. Move that here. And how we do that? Let's put it down here a bit, and then we work here. So in our build zig here, after target and optimize. So basically here, add the following. Okay, so now we need to get rid of some of the comments because they won't make any sense when I just put stuff in there. Okay, so we define a const raylib dependency, and this is B, and B stands for, okay, so this is the build dependency like this. Okay, it gets a string name, and that is raylib zig, and here it gets that target is target. Okay, so it's the same. So it gets basically the same target that we also use for our main build, and also the optimize settings. Optimize is optimize. And there's a comma, no semicolon. Okay, yeah, because it's right. So now we need here. And then it says, okay, so const raylib is raylib dependency module raylib. That's the name. Okay, so we. Okay. And const raylib artifact is raylib dependency dot artifact. Okay, so we got this, and I think we need to say that that our main executable depends on that, right? Okay, then extend the executable module imports. So we got the executable here, root module, root source file, imports. Okay. Okay, so we say something like this. Dot name is raylib and module is raylib. Okay, then after cont x the executable b at executable, link the artifacts. I must have missed it. Okay, so we want to go basically below this definition here so that we have the executable. And here we just say the executable, go away, root module, and link library. Okay. Apply to your current file shape. This is the relevant part rewritten in the style of your existing build. Okay, I think we got that. Important naming detail. In build zig zon, the dependency key is raylib zig. In build zig, you access it with b dependency, raylib zig, and so on. In zig source, you still write import raylib, okay? Because raylib zig exports a module named raylib. Okay. What you do not need. You do not need to reference. Okay, no, I don't need that. I want to remove that again. You do not need a local path dependency. You do not need this, okay, unless you want advanced options like custom OpenGL version or mscript and web support. No, we don't want it. You do not need RayGUI. For now, we don't need that, no, unless you actually use it. Optional ladder additions. If you want RayGUI 2, no, for now, no. One caveat. Raylib 6 readme in your local docs mention zig 0.16 while a project declares 17. Okay, that does not automatically mean. I think maybe we're fine. We tried it out. Okay, so let's move that over. And there seems to be something wrong here. Let's see. Oh, exit code. Oh boy. Maybe I was too fast. Okay, so let's check. Here. What's that? Okay, so that's just the original Raylib. Bindings tested on Raylib version 6 and zig 0.16. Okay, so so what we could do is we could say, okay, let's downgrade our zig version. It's probably easier. And hope for the best that we don't use something weird. Okay, let's try this out. What happens if I just do that? And I think I need to go to settings, and there is somewhere tool chains. Where is its zig tool chain? Color scheme here. Here. Okay. And what if we say here 16? Download. Let's see. Yeah, that's good. Add. Then we need probably version 16 as well. I don't know. Let's do that. Okay. So now we got stuff going on here. Where's the arrow? This allows the user to pass arguments to the application in the build command itself, like this. Yeah, we did that before. But it doesn't seem to exist here. Add pass-through. Do we have something with pass-through? No. Okay. So if that's the only offender, we don't need it right now. Okay. What now? Does it work? Ooh, it compiles. Wow. And we got our window. Okay. Okay, so that works. Okay, so we got a window now. And what we want to do is to display an image there. So we can either display an image or we draw a square and put a texture on it. We need to look up both. Okay, so let's go into our main. We got that here. First, we make the thing square. We say here, we say random gradient effect demo, close window. Okay. 60 frames per second is okay. Okay, let's keep that here. Okay, so that's the main loop. That's obvious. Update everything here, draw and draw. Okay, so now I think we need to check how we can simply draw something in Raylib, an image. Cheat sheet. Is window full screen, toggle, set window, get monitor count, cursor related function, no, drawing related function, clear background, okay. Begin drawing and drawing, begin mode 2D and mode 2D, begin texture mode. Get screen to world, no, timing. File rename, file remove. Okay, so that's not interesting. Input handling is not interesting. Okay, shapes. Get shapes, texture, rectangle. draw pixel, draw line, draw circle, draw ellipse, draw rectangle, gradient lines, draw triangle, draw polygon, triangle strip, splines, okay, textures, load image. Load image raw, load image from memory. Image generating functions. So gen image color. So we get an image. Okay, how can we from channel image format? Okay, so we got an image. The question is, can we image clear background, image draw pixel, and so on? Texture for loading, a texture loading function. These functions require GPU access. Okay, load texture from image. Okay, we got text. We don't need text at all. So this is 3D. We don't need 3D. So is there a draw image? No. Set window icon. Nope, nope, nope. Nope. Okay. Let's see if we got some examples here. Audio, core models, others, shaders, shapes, textures, maybe. Background scrolling, blend modes, bunny marks, clipboard image, fog of warframe, GIF player, maybe image channel, texture image channel, and let's update it. Okay, so what does it do? It initializes the window. It loads an image, gets the alpha channel, gets the red, the green, and the blue channel. This generates a checkerboard. Okay, so okay, so and then it seems to create. So okay, so it's basically the thing I mentioned, right? We load the image, or we have an image. We don't load it from somewhere. We create this, and then We put it into a texture. And okay, so wait, rectangle, rectangle. Okay, okay, okay. And then it says draw texture, background texture. Okay, so I mean, we can just try that, right? So we do the same. We just generate an image and then we draw it. Okay, so let's put that away and so that I have it here, and then we try this. So we got our thing here, 512 by 512, and okay, and we got that. So let's first create a an image, and I'm having just the reference here, the cheating stuff. So we want generate image something. We start very simple. So how is that supposed to work? Maybe like raylib dot gen image color. Okay, we start with that. Or checker. No, color is easier. Color. Width is screen width. Height is screen height. And color is, I don't know. Color. Is there something like that? Color dot something? No. Here, type color dot. And do we have some stuff here? Exactly, that's what I wanted. So we have brown, gold, gray, green, lime. Sounds good. Okay, so now we should have an image here. Not sure if that needs to be const. Okay, so that's the first step. Let me look on the code. So then they create a rectangle. Const rect is and how's this done? Maybe like this, RL rectangle. So we specify the type and then we can use the init stuff. I'm sorry. Okay. Okay, sounds good. So we do init 0 0 okay, I can 0, and this is screen width and screen height. Let's see. Okay. And wait, where does the okay, so we got the image here. And now, okay, so we need one thing in between. We need the texture. This is a RL texture 2D. All right. And here we say, I think here we don't need to specify the type because there is no init. We just say RL load texture from image, and then we say image. So this, although this gives an error stuff, and so does someone know Zig? So okay, so how can I say, okay, if this gives an error, then I don't know, print a message and quit. Or can I say something like catch return? Okay. So we simply catch the error and we just return. Okay. So then we got the texture and we got the rectangle, and we need to, and they unload the image. So the question is directly after. Okay, so for the moment we can do that. So, and we have the rectangle here. So, okay, so, and okay, so we got that. So what I'm wondering is, okay, so we can set up this, let's set up the example. So what we're not sure of is that we can actually access the image array, basically the pixel data from image. Any opaque, okay. Because remember, we need access to the data array to filter it. Flip, gray. Okay, so how does format and data? What's data? Any opaque. Okay, so we get this going, and then we think again if we really need a an image, or if an image is just not the right thing to do, and we should rather work with data and then put it into texture. I don't know yet. Okay, so, and here we say, so how do they do that? So they just say, what I don't understand is, does the compiler know when I stop doing something? Because it says, okay, let's defer the end drawing stuff until everything is done in this block. That's how I understand it, okay? So, but what if I want to put lots of stuff down here, but I don't want to draw anything? Okay, so we don't care. So clear background white. We don't do that. And we simply say draw RL, draw texture, and then we go texture. What is draw texture pro? Wait, need to check that. Draw texture pro. Draw a part of a texture defined by a rectangle with pro parameters. Okay. All right. So So we want the texture here, then the rectangle, then rectangle source, rectangle destination. Woo. Let's look to the example. So background texture. Maybe we don't even need that. Let's do that. Draw texture. And it says white. Color is white. Okay. Then rl dot color dot white. Okay. So let's run that. Oh, exit. So what did I do wrong? Unused. Okay, so the rectangle now is unused. So I think the trick was to say, yeah, we use it, but we don't use it. Perfect. So we got an amazing green rectangle. So now we're stuck with this. We're stuck with the decision how to access basically either the image data or the texture data. Can we create a texture from data? Let's look. So since we know how to draw a texture, so we can load texture from image. That's what we used. What is update texture? What is that here? Update GPU texture with new data. Pixels should be able to fill the texture. Okay. So, but how do we create a texture in the first place? So let's say we use that const pointer to pixel. So we got this here. Let's start at the top. Begin texture mode. Begin drawing to render texture. End texture mode. What is that? what we got here? Texture image drawing. So let's see. They load a cat, they crop the cat, they flip it, they resize it, and they load a parrot. So that doesn't help us. Image draw pixel. Draw on the image with a few image draw methods. Okay, so we don't want to draw on something. Image draw text, unload font. And here it says just clear background, draw texture. Okay, that doesn't help. Here, there it is. Draw raw data. Okay, so wait. Dynamic memory allocation to store pixel data. Using Raylib provided memalloc that uses default Raylib internal memory allocator, so this data can be freed using unload image. It also uses Raylib. Okay, so size of color, and then we got pixels here, and then they go through. Okay, so they simply create an image. Load pixel data into an image structure and create texture. No, we can assign pixels directly to data because color is RAG8B8 and the alpha channel. Data structure finding the format must be set properly. Okay. So what pixel formats do we have? Pixel format uncompressed. So is there also something pixel, how is it called? Pixel format without anything. Pixel, no. Okay, let's check here. So we have image, image. Where's the image? So image format is pixel format. Let's look what we got here. So uncompressed, and they used uncompressed. Uncompressed grayscale, that's what we want. Okay. So that's the one we want. Okay, so let's say we go back to our code and try this out. So first, really simple. So let's say we got a const. It can't be const because we want to assign it. Var image array, and this is comp time int, and we should be able to say, can we do that? This is of type screen width, screen height, and should be unsigned 8. Does it work? Wait, I can do F. I can do that, but it's not the right one. Sig data types. This one. So where's that? So, oh, it's I. But it's not I. I want U8. Didn't I write that? So unsigned 8-bit. Okay. Then we say for screen width, and we just go through and say this is what width is X. Maybe we should turn that around. Screen height, and this is Y. And I think there needs to be a -1 here, right? And 0 to screen width -1, and this is called X. And then we say image array is yx is, now we need standard. Is there random? Oh, don't tell me. Okay, doesn't matter. We will create it one by one. uint returns an evenly distributed random unsigned integer between 0 and at most. Perfect. What's random? So we need a random generator.
Yusidon. I have to go, but this is really interesting what you're doing.
Ah,
I'll come back next time, Scissor.
wait, I need to show you. Right, I mean, you haven't even seen what we're doing. Did you saw it? So, wait. So the end result will be this here. That's the end result. And it's 3 lines of Mathematica code. But we will get it going in Zig. And if it's the last thing I do. But thanks for joining. Was pretty because it's awesome late here. I'm not sure how late it is for you.
Yosidon. Wow,
Yeah,
cool.
it's really simple, right? It's just these 3 lines. That's all that's needed in Mathematica, and we just need all the setup in a low level language. So that's what we're going for. Thank you for joining. See you next time. All right, so we need a random generator, it seems. So const rand is so standard random. Probably just one of these. I don't know. Okay, so we need to look into the documentation again. So where is a random generator? Arrays, vectors, pointers, slices, structs, union, switch, while, for. It's probably in the standard thing and not here. SIG standard library. There we go. Random. There we have. Okay, so the engine provides here. The engines provided here should be initialized from an external source for a thread local crypt. Okay, we don't need any of that. We just need simple numbers that are not the same. Fields. Okay. I don't know. I don't know why there is absolutely no documentation whatsoever. So what's the right way to generate random numbers in Zig? Standard POSIX get random. Standard POSIX get random. Standard mem as bytes from seed. And then fail to get random seed. Okay. So let's do that. Like this. So now we got the random generator, and I think the only thing we need to do is rand dot rent dot hello. Oh no, something's off. Unused capture, unused capture. Okay, I know that's unused, but what? Oh, okay, here. No, it's still something is really wrong. Where is Mac? So do we have? Okay, so something is off. I don't know. Let's say if that, then we say y minus x else x minus y. So something is off, and we will get an error. So see, unused local. Okay, understand. So POSIX has no I don't know. Right? Honestly, we don't care. This is no, it's 42, of course. So what is wrong with seed? It's never mutated. Okay. Better. So still something is wrong. I don't understand. Standard random default init. Root source file struct standard has no member named rent. Okay. Because it got renamed. Now let's do it like that. So no, let's first unsigned 8-bit int cannot represent all possible unsigned 64-bit values. I know. Okay, but that's the only error. Okay, and we wanted to replace it as well. That was only a placeholder. So rand dot so how did they do that? Float. And we want uint at most. Type is, what did we say? We say u8, right? And then at most 255, like this. So what's the error here? Pointless. Yeah, it is indeed pointless. So we got that. So now does it run? Thank you. Okay, so that's okay. So now we should have a random image. Not yet, but close. Okay, that only took half an hour. So, and then we need the example where here. Okay. So, and now we say, we skip that here completely. And we say const image is, does it work? Ah, okay, wait, I need to specify the type. That's clear. That is rl image. Yeah. And we say dot init. Init raw file name. They don't set a file name here. Maybe, I don't know. So what's, if I say undefined here and I say image dot, can I do that? No. This will definitely go wrong. We'll just try it out. So data is image array, and we use a two-dimensional array. Okay. I don't know if that's okay. We will see. Can I, okay, so wait, so can I do that? here. Like this. Image array, I think a comma. Format is RL image. Where's pixel format? Pixel format. Uncompressed gray. Uncompressed grayscale. Dot height is screen height and screen width. So like this, can I do that? Okay. Now let's see it explode. Bam. Exit code 1. Expected type any opaque, found this U8. Okay, any opaque. So we need to cast that to a different type. Let's see. Address space cast, align cast, bit cast, pointer cast. Converts a pointer of one type to a pointer of another type. The type is the inferred result type. How would I use that pointer cast thing? So value like this, and it just does it? That can't be right. Zik. What does it say? Expected pointer type. Cast 1. Okay, so let's see. Read more. If you want any opaque, I think. You want any opaque. It's very poorly documented though. And foo, but really. That's weird, right? Because okay, so maybe no. Missing struct field, mipmaps. Okay, so that's better. I think it's at dot mipmaps is 1. Okay. So that didn't work. as expected. Okay, so wait. We load the texture, but I think we're unloading the image, and I'm not sure it's allowed to do that. At least not here. Let's put it there. Not sure. Let's see. Oh, there you go. So so what happened here is basically that we created the image from an data array that we created, right? So we have the rights to free it, and unload image will definitely try to free the underlying array. So that clashed. So now we got perfect noise, which means nothing, right? Because it's okay. So we got that. So, and the only thing we have here now is
Broston 45. Finally, hee.
yeah, I know. We managed to show a random noise image in 2 hours. Okay, so we got that. um, we got that. So wait, let me think. Okay, so there are several steps that we need to do. So now we got an arrow again. So maybe we should not, we must not do that. Because otherwise there are only values in here, and the pointer is the only thing. So let's just start it again and see if it throws an error when we close it down. No. Okay. So we're not allowed to unload the image because this is a this is an array we create, so it will go out of scope after that. Okay, so let's go to filter. Filter's already pretty long. Okay, let's do it here anyway. So what we got is, or what we need is a function that's probably named something like filter raylib image. No. Data, because we don't give an image, we just give the one-dimensional array. So, and this will get the image data, and the image data will be of type. It's a one-dimensional array, and it's not a matrix, right? So we store it in one direction only, and it just takes the single rows bit after bit, and this will be no. We don't do it like that. No, we don't do it like that. We will give a two-dimensional array because we can. How do we slice that better? Let's say we do like that. So this is U8. And we will simply change the data. Perfect. Let's do it like that. Okay. So this will be void. So what we need to do here is filter in X direction, filter in Y direction, transform data, image data to F32, and the question is, so here is extract all rows, filter in X direction. Okay, yeah, I know how we do that. Okay, so extract all rows, filter in X direction, and then result, or result is the X, extract all columns, filter in Y direction, result is dy, and then we will have to do another loop where we say calculate the square root of dx squared plus dy squared, and upscale and flatten, upscale, flatten, and transform data to U8 or into U8 data buffer. So these are the steps we need to do. So and since we need separate images anyway, okay, let's start here. So let's don't do this step, but do it instead here for each, so that we have two separate temporary images that are created from the thing. So extract all rows. And here we also need width and height. And how can I say comp time something? Is that possible? Can I do that? Is that okay? So because this is available in compile at the compile time always, so I believe what we can do is say var dx image or image is here we say this, and this is width times height. So that should be possible now. F32 undefined. Does it work? Let's see. Okay, and then we just do a loop. Yeah, we do it like that. We do it like that. So here we simply can say for 0 to width height -1 is data I. So this probably won't work because we need to say, maybe it works, I don't know. Let's see. Let's first assume it works, because this is U8 and it needs to be cast to F32. There was something like std math float. Where was it? Was math? It was something else. Mem. No, it wasn't mem either. Float from uint. Float from int. Oh, it was one of these add things. Okay, so then we got the X image. And I think while we're at it, we can do the same for the column image. Okay, like this. Probably there is a way to copy the image. Maybe we should do that instead. A bigger mem copy is better than. Can I do that? Can I do something like dy image is dx image dot mem copy? Okay, no. For the moment, we don't care. For the moment, we will do it stupid like this. dy image is the same. Okay. Okay, so now we need to filter in X direction. And for that, Okay, let's use the thing I implemented, because now we need to double the memory as well. I mean, it's just a small image, but so we say here for to height okay. I'm not sure if that works. Let's see. So this is y. And here I want to say something like dx image. And can I slice that and take while switch enum slices. Something like that here, exactly. If you slice with comp time known start and end position, the result is a pointer to an array rather than a slice. Okay, so but now, okay, so we will change the thing. So what I want to say here is, well, this is basically from, okay, so this goes from y to width times y plus 1. And I have no clue if that, I think that doesn't copy it. I think that just, so, but in that case, we probably don't need to copy. So let's see if that works. And then we want to say this one. So for the moment, we put 0.5 here. Input is row, output is, and I'm not sure if that works, and the allocator, so I need to give the allocator here. Okay. I think it's standard mem allocator type, like this. And here we just say allocator. Okay. And then it filters this thing. So we already got an error here. It's never mutated. You are wrong, boy. Probably because I need to say end. Okay. And that should filter it. Okay, so that should basically go through, and that should be the DX image. So, and we leave that part out for the moment, because here we really need to either copy the data, because we need to go basically in the other direction. We need to jump from row to row for one column, and that's not possible with just with taking slices out of the memory. Okay, so what we can do here is say the following. So we say var maximum is, I don't know, comp time float. We can give the type here, and we say we need to go through once to get the maximum. Okay, I need something to drink. 1 second. -1. So we go through the whole array. And here we want to say, okay, dx image on position 1, on position I, is the same as dx image and then since we don't have a second one, we just take and hope that works math square root of that. Okay, so we got that, and then we say max is if the x image on position I is bigger than max, then it's the x image on position I, and otherwise it's simply a max. Okay, so now we got the image. And now we need the final loop where we rescale everything and say basically the same thing. But we say data I is dx image I divided by the maximum times 255, and we say here float int from float and hope for the best that it can do that. So that's not needed. Okay, so let's see how much this explodes. So we can go to here and first we just try it out. Okay, so we say filter dot filter arraylib data. We put in image array. We say this is screen width because it's exactly the size of our image. This is screen height. We don't have the allocator yet. I think here, just on the heap. Okay, so let's see. Okay, no. Okay, U8 is wrong. Why did I say U8? Okay, where did I say that? Oh, I say, okay, sorry. That's stupid. So, what do we have? Something like this valid. should be enough, right? What did I write here? Where? Here. Standard data. What? Who put that in? And I was seeing before that when we were working down here and we used data somewhere here, I saw that this was unused and I thought, okay, so is it a glitch in the highlighter? Because I definitely used it up here. Okay, so it's spec type const, but it found so this is a bit tricky. Let's not make that const. It's still errors. Row. And found a pointer, so wait. But now it says, okay. But when I move that to const, it shouldn't. Error. Error union is ignored. Where? Here. So is it enough if I say try? No. So I think I need to understand the thing with the errors. Wait, node function cannot return an error. Where's the so okay, so try will basically promote the error upwards. So when an error happens, and if I do catch, I just ignore it silently. So let's do try here, and up in this definition, we will say, okay, we promote the error. So how is it done? Like this, and then we need to fix that in main, I think. And can I do here a try and it simply fails? Is that possible? Ooh. Well, that doesn't look good. failed command. Okay, no, then let's not do that. Oh. Oh, I hope it doesn't crash something. So if I leave it out here, okay. Right, so when I do that, I have basically the possibility to say here stood what was it, debug print error in filter. And can I pass the error? Do I get the error? I don't know, not now. Error and filter is enough. Okay, so this is not good. Okay, and what if we... So what if we don't do this at all? Sorry. So, okay, so it's definitely this one. Filter raylib data. Okay, so let's see. Give me... So I think that's the right console, is it? Yes. Okay. Let's make a new session. Wait, then we want to know. Okay. Your task is to explain in detail how arguments, arrays, pointers, and slices work in the following examples. And if I'm doing something seriously wrong, in main, it's in source main zig, there is the following snippet where I think snippet was spelled with a T, where I try to provide image array, yes, as an argument which should be changed or mutated by the function. Did I copy that? Okay, so that's the first one. Second, in. So in filter, in I have a dx image, and I try to filter it row by row in the loop. Is there, okay, what I'm doing wrong? What am I doing wrong here? Inspect the rest of filter.zig as well for similar issues. I'm very new to Zig and want to understand syntax and semantics of arrays and pointers in that language. So go. Okay, I like to read these things for some reason. So I'm exploring whether I can use slicing syntax or image array recursion. In Zig, array gives a pointer to the array, which can curse to a slice if it's passed to a function that expects one. For clarity, some func array is explicit. I think idiomatic usage would be image array as a mutable slice. I also need to explain how filter array data takes data, allowing mutation of the original array while working with the X image. Yeah, I know. Because initially we set it up differently, right? I thought that we use the filter, so it gets basically two arrays, one as input that is not mutated and one as output that it's written, right? Where it has the right to write in. Let's see if it can figure it out. So the main issue is not pointers are bad, but that you are mixing up arrays, slices, and half open ranges. Okay. Core model. An array value with exactly n elements. Okay, so we understood that because we used it. That's a pointer to one thing. Okay. There's a pointer to an array. It's a pointer to an array. So I'm probably still confused because in C, basically, an array can be represented as a pointer to the first thing, and everything is to the first element, and everything else is basically the next memory locations. But okay, so a slice, that's a slice. Pointer plus length, a view into existing memory. Okay, slice does not copy the data. Okay. So in main Zig, okay, we do that. Image array is an array. And image array is a pointer to the whole array. Okay. That's good, is it? But filter array lib data once, okay, once the array itself. So the right mental model is just give the thing as a slice. Okay. That gives a mutable slice to the array contents. Okay. If SIG accepts and image array there, it's through recursion, but it's not the clearest form. Use that for slices. Same for this call. Okay. Okay. So let's fix these first. Okay, we can fix it down here as well. Oh, well, although we don't. Okay, so let's do it simply like this. So this seems to work, but okay, so this line creates a slice into dx image. Okay, it should not copy it, right? Because we want to change dx image. Is an in-place operation on that row, and that's okay. That is valid if the function is written to support, which yours mostly does, okay? So the row slicing itself is not the serious bug of by one loops, okay? You repeatedly use the pattern like, but I thought we need to use -1. What? I thought they were all inclusive. You sure this is the last element? Unbelievable. Let's see. I want to know that. So let's get rid of this here and say, okay, 4, 0 to screen height. And we want to say std debug print, and then we just say, and we make I. Okay, go ahead and show it. Where is it? Oh, it's really missing the last one. But didn't we read yesterday that and it was so confusing. But then I'm doing it here wrong as well. I'm doing it wrong everywhere. Okay. Where? Here. Okay, so we do it wrong here. We don't copy all the data. Obviously, we do it right here for some reason. We do it wrong here. We do it wrong here. There are no loops here, are they? See here. I'm doing it wrong here as well. Let's hope we don't break anything. And I'm doing it correct here. What? Okay. Derivative filter 1D leaves elements uninitialized. In derivative filter 1D. Okay, and that's probably wrong. Backward pass never writes index 0. dy image is never used. Okay, because we didn't use it. I know that's just apps, but we will use the other image as well, and then it's not just apps. You need both buffers. Okay, max can stay 0, 0. If the whole image is 0, then okay, yeah, I understand, and then it goes nuts. But it won't be, and okay. All right, so data means a mutable view of caller-owned bytes. Okay. Writing data I mutates the original image array. Okay. Okay. Row is a slice into the X image. Mutating row mutates. Okay, that's exactly what we wanted. Passing row as both input and output means filter this row in place. Okay, that part is conceptually fine. One more important one, you declared filter raylib data as this, because width and high are comp time, the array sizes inside the functions are compile time fixed. That's okay for your current const screen. Okay, but it means this function is not truly runtime generic yet. Okay, that's okay, because we intended to just do it compilation time. If you want arbitrary image size later, you will want runtime use size dimensions and heap allocated buffers or slices. Okay, so probably one core thing we did wrong. So do we use allocator now? So we don't, and that's probably fine. So we don't get shouted. We don't get shouted at for leaving that unused. Okay. Okay, so we still got this weird bug. And it stays gray. It's coming from the filter. What if, okay, so what if we don't We don't do anything with data, and we just leave it. No. So as soon as we call it, hmm. Okay, so let me take that here. Can I copy it? Okay, so the problem is, as soon as I have, how is it called? As soon as I use filter raylib data in main, I get weird linker errors that are not there when I comment out the part where this function is called. Please run this for a few seconds. I hope it can do that. Note that in filter raylib data, I commented out where I rewrite data into the input buffer. So all I'm doing is reading from the data array, and still the error happens. Linker error happens. Do I still have so let's see if it can do that. Oh god. So let's see. I can't run Zig And this read-only phase, okay, but I still can tell you what most likely happening. Your array size pointer is not the linker problem. Okay, most likely filter raylib data pulls in standard math. Okay, through normalization factor and so on. Your zig does not explicitly link libc on the executable, but it's not coming from libc. It's coming from somewhere inside raylib. Do I use image array somewhere? No. Oh yeah, wait. Not a slice, but I need that now, right? Do I? So it says that the backwards pass never never writes index 0. Okay, so because okay, I see. But that shouldn't be a problem, right? Okay, so we need that, right? So, and here we start from n minus 1 minus index. That should be it. So, because in the first iteration, index is 0, and we start out with n minus 1. As the current index, which is the last index. And here we end up with n minus 1 in this, and then we have n minus 1 minus n minus 1, and this is 0, so it writes the first element. Okay, so now it should write index 0. The final combine used uninitialized in earlier versions. Okay, are huge stack allocations. That's not a linker issue, but it's fragile. Okay, so, but how? Okay, okay, good. We care about that later. Try to run it now. Come on, I said run it for a few seconds. Could have just... In the current code, the row slicing is completely incorrect. For y1, the row length is... Yeah, I had this because otherwise I couldn't debug. Okay, so we need to re-add that later because I don't think it's the problem. Why should it be? The row slicing is wrong. Yeah, because we need only a plus, right? Okay, so right now it starts at 1. Okay, so let's fix the... let's look at the filters first. Okay, so in the row seems to be the culprit here. So it's okay, so that's completely stupid. And it should no. Okay, so this is completely stupid. So what we want is if we start at y, and we go to So, okay, so for y with 0, that means we start from 0 and go to 1 times width, which is 512. Okay, so for y1, we start from, okay, so that is also not correct, because there needs to be a +1 somewhere. Maybe it is correct, because that is exclusive, right? So that goes to this, which are 512 elements. So, and if we have y1, then we have 1 times 512, so we start at 512 and we go until y plus 1, which is 2, times 512 is 1024, but since it's exclusive, we go to this. So that should do the trick, right? Okay. That was fast. Oh, what did I do? Okay, so let me see. Because now build zig. So who removed? So until we need to debug something, let's keep the LLM stuff out. So, and there's another thing wrong. It seems I initialized the data array somewhere. For 1 to n. No, it doesn't, because, okay, so I do fix that. Okay. So that works now. Okay. And let's go here and put the assignment back in. Not that. So finally, okay, we got a filtered image. Yay! So, and for good measure, now we can do what we try to do. So we have this filtering of the data, and here and we want to do that in the while loop. So we want first the filter, then we want the image from it. Now we want the texture from it. There you go. Okay. And then we draw. I think we don't need the rectangle anymore at all, right? Because we just set it in the background. So texture, texture. And the filter already rescales everything. So I think we can kick that. So let's see. Okay. So I'm not sure if that's the right move, right? But at least it works in one direction. Okay, now okay, so and I want to clear that up first. Okay. Now it seems to work. So inspect the raylib code in source main. What I really want is to continuously filter the image array in the main while loop and display it Right now I'm doing that by creating an image and applying the image to a texture. This seems like no. This doesn't seem to be the best way. Are there more concise approaches to do that? Oh, wait. First, I want to tell it to plan so that it doesn't write in my code. Okay. To create the texture once, then update its pixel each frame. Okay. Your current loop is expensive because load texture from image creates a new GPU texture every frame. That is the wrong level of abstraction for it. Exactly. Best approach, keep image array on the CPU, filter it in the loop, create texture once before the loop, and use RL update texture each frame with the modified pixel buffer. Okay, so we use that. We use that. We do that. Okay. Ah, okay, so what? So why would I need? So I need an image first just to create the texture, and then I can simply push. Okay, let's do that. I think, so it's a bit weird, right, that we just need the image to create the texture from. Okay, so I don't need that. That's a good hint. Okay, and then basically defer RL unload texture text. So that, and that should not happen here. So this goes outside the loop. This goes outside the loop, okay. And inside the loop, we filter. Okay, so and here we said we catch that, we don't catch it, we try it, and if it fails, I think it just promotes the error upwards. Okay, so we do that here. And then, okay, what does it say? RL update texture text, and this is the pixels, and then we say, okay, pointer cast image array. Okay. And then we should get rid of all these, right? Texture loaded successfully, because we don't create new textures. Perfect. So, okay, so filter raylib data definitely needs a sigma f32, and we use that where? Here. Okay, that should be it. And then we can go back and can go very to the top. So const filter sigma is 15. And then we can go into the loop where we filter here. So there you go. And that should look brilliant. And then when you really need to think. Okay. So now we need to, oh God, it's so late. Now we need to basically implement the Y direction. Okay. So width, and then we go X. So, and here we really need to we can't access basically the whole slice. At least I don't think it is possible. The question is, okay, so we will do it stupid first and then see if it works. So const column is, in that case, so then we can say column of y is no, we just transposed the whole image. Let's just transpose the whole image. To not confuse anyone, we go like this. And then we say dy image of y times width plus x equals the data. How did we do that here? We didn't. So we can get rid of that and can say float from int data x times width plus y. Okay. Sorry, and then we have all that. And hopefully now we can say const column is dy image of okay, sorry. So we need to do that. We can't do it like this because we need to transpose the whole image first. And then we can say, let me make it small, I can scroll up. Const column is dy image of, okay, so then now I can do basically the same thing, right? X times height plus and then x plus 1 times height. So we won't notice any bugs here because it's a square image. So and then we say try derivative filter sigma column and allocator. So, and now we go through everything and do the same thing for the dy image. Or can't, and we need to say it like this. And we can do the transpose in the same loop. And store everything in the dx image. I hope that works. So we got that plus dy image, and here we need to say x times let's try that plus y. So and here we say y times width plus x is bigger than max. Okay, and if we're done, we can do max is if max is smaller than, I don't know, 0, 0, 1. Like this, so that we don't run into a division by 0. And then we should be able to go linearly through the thing. I don't know. Well, So, and one thing we want to do is oh Christ, then we need another one. Okay, so because we want to keep sigma and factor is also F32. Float from int data I. What? Okay. And basically here we say factor times original plus 1 minus factor times this scaled. And factor we want to have okay. That's probably too much, right? Let's try 0.5. Okay, that looks beautiful. Okay, let's see, because we really didn't do a good job of doing that very performant. Ooh. Now we're dropping frames. Okay, let's see if we can 24. Okay, so I think this runs really slow, but I understand it because we do everything in serially, basically. By no means we do anything in parallel, right? Okay, let's see if so now I implemented the whole filter. However, I think all these loops are far too slow. Can you inspect source filter in detail and make suggestions?
Broston 45. Almost there.
For bigger improvements. I mean, we want to, right? We want to colorize it, and this is another thing where we need a loop to go through. But I think, I mean, it looks good already. So what happens? So we have 15 here. What's when we use 5 now? No, I don't like that. What if we use? Where is it? Here, okay. So we used 2 times the gradient filter, but and then we adjusted it, and we used the filter length of 5. So let's use that, and I think 2 times the gradient filter is a factor of, I don't know, maybe like this. No, that's it's really nice because that's so. I mean, we replaced basically, I think, a 2-dimensional filter with just 1 dimension, doing it line by line and row by row, and it has really a different behavior. Okay, so let's increase that thing. Okay. So, okay, so what does it say? Oh God. Okay, so that will be the last thing we do tonight. There are a few big wins here, and most are larger than micro optimization loops. Highest impact: stop allocating inside derivative filter 1D every call. Right now, every row and every column does allocator alloc that for. Okay, this is a lot of allocation churn. Better allocate scratch buffers once outside the frame loop and then pass them into the filter, or make them part of the reusable context struct. Okay, so let's skip normalization first, because I think we don't need it. So, because we normalize it in the end as well, anyways. So filter. That thing here. So now let's do this. Scaling is 1. There you go. And it should look exactly the same because we okay. And then we do, so for each row and each column we do all this stuff here. Okay, so what else? So I don't want to send it. Okay, so I don't want to send it in. So built-in release fast. Okay, so that's what something we can do. But so okay, let's try that first. So I build help. No. That what? Ah, I know, because we made some changes here, somewhere in the where's the terminal? Here. I think I did some changes here, didn't I? Here you go. So here we want to have 16. Apply. Okay. Close this terminal. Okay. I don't know. So basically we want zig build run, and then we need fast debug, release save, release fast, de-optimize. So we want zig build run, minus D optimize release fast. Christ, takes quite a while to compile that. And here we again we got the LDD stuff. Okay, so what happens if I now do it in, I don't know, bigger? Nah, it's not really. So it is just expensive, and we're allocating all the time. And let me, so I think it's a bit, can we transform it once more? Probably not, right? Because we, what if I just, I mean, what if I add, let's say, 30 here? Does it still work? No. Okay, because we wrap around, right? So int from float.
Broston 45. Why is it so slow?
Yeah, because it's slow. Because it's simply slow. So the thing is, right? Okay, let me just do that. And so, what? Raylib data zig main. What? Oh, 1 second. Okay, so we can't fix it that it's so dark. Okay, so let me go back. So then I explain. So and that will be the last part. So okay, so for when we run that, so for every frame that you see, right, we need to calculate a filter of the image. And what happens in this filtering is that it's basically two filters that happens on every image. So the first one goes through every row and basically goes once there and once back and calculates what's called the gradient, right? So if you have an edge there, it will basically highlight the edge and make it brighter. So, and to do that, there's quite a bit of math behind how to do that exactly. So if we go a bit into the code, so we ignore that stuff. We ignore that stuff because we don't use it right now. But basically, this is what happens for each row of the image and for each column of the image. So we computate that. So once we go once
Cutting
forward,
Wonderland GZSGBRT1.
we go once
iViewers
in that direction and back. And then for each column, we go basically down and upwards, right? But for each column and each row, on every frame, we need to do all the math here. And that's just expensive. So, and that's not all what's expensive, right? So because I just can't do it on the image, because the image that you're seeing here is a texture. And the texture is, in that case, an array or a matrix of unsigned numbers, which is from 0 to 255, whole numbers, 0, 1, 2, right? And if you're at 255, it means white. And if you're at 0, it means black. That's it. So, but my filter doesn't work on whole numbers, right? It's math, and it needs basically floating point numbers like 1.3 or 1.5. So the first thing we need to do is we grab the current image and then we filter it. And to filter it, we need to convert it to floating point numbers. So, and then we need to filter every column. So we need to copy out every column and every row, filter it, and then in the end, put it back together, right? Because we can't do it in place, because when I change basically one column in the image, right, I can't do the filter in the other direction because it would use basically the image that has already been worked on, right? And we want to separate these two things. So there's a lot of memory copying going on, of memory allocating going on each frame, and that's why it's so slow, right? And usually you don't see that because all the computation here happens on the CPU, and what you see in games or in other effects, right, it happens on the GPU, and there you have usually matrix operations that are not going through every row and every column basically like I need to do it here. So that's why it's so slow. And in other languages like Python, for instance, right? You have libraries for that. So you have a library to do filters and or to do the convolutions like I do here, right? So the example here that runs pretty good, if you consider that it's an interpreter, right? I mean, now it's slow as well, but it's slow because it's colorizing every frame. If I don't do that, it's pretty okay. It's pretty fast. All right, I need some sleep. We managed to at least to see something. It's a bit unfortunate that
Broston 45. Yeah, I understand. Nice.
yeah. So if we don't colorize it, oh, I forgot something. Right, this is much slower, much faster, but it's also 256, so we can do it on. So here we do it on bigger data. So if we do it on the same data, oh no, oh god, then it's probably okay as well, right? The thing is I can't increase the size here because basically here I can just make the image smaller or bigger, right? But that doesn't work here because I have a fixed window width of the size of the image that I'm using. Okay, anyway, I think it's okay. We got pretty far. And let's see. I will go to bed now. I hope you have a nice evening or whatever it is where you are. Morning, afternoon. Let's see what we do next. Yeah.
Broston 45. Me too, ha.
Yeah. So have a lovely evening or have a lovely night. See you next time. It was really fun that you stayed here and basically you were my company for the night.